Hi guys, today's problem is Task D AtCoder Beginner Contest 254. The input is an integer n from 1 to 2 times 10 to the 5th. The problem is to find the number of pairs ij of positive integers at most n that satisfy I times j is a square number. So take an example of n equals 254. We have like 5 times 5 which is equals 25, and 12 times 3 equals 36, and we have a larger one, 250 times 250. We have so many pairs other than this. So how should we solve this? Firstly, I gave you a direct method. So let S equal I times J and S be a square number. Since I and J are between 1 and n, S has n ways from 1 squared to squared to the n squared. So fix S and let S equals m squared for some n. We need two conditions for a proper pair of ij. The first, S can be divisible by I, and the next is the quotient of S divided by I is at most n. If they are satisfied, then we get a pair of ij as desired, because j equals the quotient. So we have to find all of ij. You can write the code easily, and this is correct in theory. However, it fails because of time complexity. It fails. It is because S and I range from I to n, and n is at most 10, about 10 times 5. 10 to the fifth, sorry, 10 to the fifth. So the order of the four-time complexity is 10 to the 10th. To give a correct answer for the AtCoder contest, the complexity is at most 10 to the 8th in general. So it fails. This method is not so good, so change our mind and try another way. We fixed S and I in previous way, but now we only fix I. Take an example of I equals 240 and think about the requirement for J. What is needed for J? So then you realize we need the non-square part of I. Which means we should divide I into the square part and the non-square part. For example, since 240 equals 2 to the 4th times 3 times 5, and the non-square part is 3 times 5. And 2 to the 4th is square part. Since I times j is squared, j has to contain the non-square part of I. So in particular, j must be equal to 3 times 5 times n for some n. And moreover, n must be a square number because I times j is squared. Therefore, so j is like 3 times 5 times 1 squared, 3 times 5 times 2 squared, and so on. And we have a limit that is 3 times 5 times n squared is less than or equal to n. This is a requirement for j. Therefore, uh, uh, n is at most n the square root of n over 3 times 5. For each I, we answer the maximal integer n, which satisfies these equations, this inequality, because it is precisely the number of j for each I, for each fixed I. So this is the for code. The key factor is to find the square part for each I. The non-squared part of I. Actually, the way. So first, let p equals 2 and divide I by p squared. As possible. If we can't I anymore, then let p equals p plus 1 and try again. But if I is less than p squared, then I is never divided by p squared, so break the loop. And the I after the operation is I is a non-square part of I, so you should return I. This is a way of finding the non-square part of I. So finally, let's check the time complexity. Since we fixed I, so since I range 1 to n, and n is almost 10 to the 5th, so we have 10 to the 5th. And then computing the non-squared part of I for each I, the operation ends before I is less than p squared. So the loop ends at most square root of n times, and which is about at most 10 cubed. Therefore, the order of complexity is 10 to the 5th times 10 to 10 cubed, so which is equals to 10 to the 8th. So therefore, it is enough to answer the problem. This is my code. That's all about task D. So my AC code is on the description. So thanks for watching.